In this video of our final exam review, I will be going over, sorry about that, guys. I will be starting at now number 13. So I'm going over number 13 up through, I believe I'm going to be ending here at number 26 or 27. Yeah, number 26. So here in this video, I'm going from 13 to 26. So now with question number 13, you are identifying which equation in factored form represents the table. So first off, remember factored form, you are then making sure that you change the sign because you're now writing in factored form. So first we need to identify the zeros, the roots, the x-intercepts. So like here, -2, 0, -1, 0, 1, 0, and 4, 0. Now 0, 8, this is the y-intercept where it's crossing the y-axis. So we do not need 8 or 0, 8 as part of our equation. So that's why here A and B are not a solution. But as I go through to identify, that's why the answer here is B, because you need to make sure to change the signs. In question 14, we're looking to see which of the following statements about the function is incorrect. So we're looking for which statement is false. So A, there's a negative leading coefficient. Well, notice how both arrows, the ends are both pointing downward towards negative, making this a negative leading coefficient. So this statement is true. The degree of the polynomial is 4. So remember now, I'm going to look at the multiplicity to make sure if they add up to 4, because that's your degree. Here at a slice, it's 1. Here, a bounce is 2. And here, another slice, which is 1. Notice how they add up to 4. So the degree is 4. So this is true. The end behavior as x approaches positive infinity. So as we're going to the right, what direction is the right side of our function approaching? Well, notice how it's going down to negative infinity, but this says positive infinity. That's why the answer was C, false. Now, for those who thought maybe it was D, that there are two intervals where the function is decreasing. So notice how here, remember, we always read the function from left to right. So even though this arrow is pointing down, remember, read it left to right. Notice how this interval or this section is going up or increasing. However, this section from the maximum point is decreasing. So here, 1, 2. So notice how there are your two intervals where the graph is decreasing. Question 15, you're considering which statement is true about the graph. Now, again, notice how we're focusing on one specific interval from 0 to 1. So from 0 to 1, which means I'm focusing on this section of our graph, values, which are b of x here in this case. Notice how this portion of a graph is below the x-axis, which are in the negative values here. Notice they're negative. So I'm going to mark off A and B because these say positive. Then read it left to right. Notice how the graph is decreasing. That's why the answer is D. Now, question 16, this is a review on which value of A makes this statement true. Well, I notice subtraction here, so I'm going to first distribute negative or -1. So I'm going to bring down 9 plus 2i, but now minus 12 plus ai is equal to -3 plus 8i. Now, if I'm looking for the value of A, notice how A is complex or imaginary. I'm sorry about that, imaginary, because this says plus AI. So I'm just going to focus on imaginary parts, your like terms. So that means I have 2i plus 8i is equal to 8i. So here I'm just going to solve 2i plus ai is equal to 8i, which means 2 plus what is equal to 8? 6. That's why the answer was D. Question 17, you're factoring completely. Now, you could also, if you're stuck here, notice test taking strategies, how we have a GCF of 2. So I'm going to first take out my GCF of 2. So now I've got 2 times 9x squared from 18 divided by 2 plus 49. Now notice we do have a sum of two perfect squares because we can take the square root of both. So because it's a sum, we do need I in the factored form. So I'm going to mark off B and C. That means here the square root of 9 is 3, so 3x plus 7i. Square root of 49 is 7. And then 3x minus 7i. That's why the answer here is D. Now question 18. We're used to, with our solving by square root, always adding or subtracting first. But notice how here the x plus 12 is grouped together inside the parentheses being raised to this power, this exponent. So I can't subtract the 12 yet because all of this is grouped together, which means how do I get rid of that? Well, what's the opposite of squaring? Take the square root. So that's why we're going to take the square root first to get rid of our exponent here. Now I've got just x plus 12, which is now equal to the square root of negative 25, which is plus or minus 5i. Now I can solve for x and subtract 12 from both sides of the equation. Now, can we subtract these? No, because negative 12 is real and 5i is imaginary. So we're going to leave it negative 12 plus or minus 5i. That's why the answer here is B. Question 19. We're identifying factors of this polynomial here. So what that means is if we're given the answer, the polynomial, and we're looking for factors, we're going to divide. And then also remember that if it's a factor, that the remainder is always going to be 0. So I'm just going to go ahead and set up synthetic division here because x has that coefficient and exponent of 1. So again, here with synthetic, change the sign of the divisor, so negative 3. Then your coefficients. Notice how we don't need a 0, no missing terms. So 1, negative 3, negative 4, and 12. Then I'm going to bring down 1, and then always multiply below the line. Negative 3 times 1, negative 3. Then add above, you get negative 6. Then here again, multiply, you get 18, but add to get 14. Then here, negative 42, you have a remainder of negative 30. But in order for it to be a factor, it has to have a remainder of 0. So A is not a factor. Now keep in mind, we're selecting 2 that apply. I forgot to mention that here and pay note to that. Now let's go to B. So B, again, change the sign of the divisor to positive 2. Then set up the coefficients. And let's see if we get a remainder of 0. Bring down 1, multiply. So that gives you 2, add, you get negative 1. Multiply to get negative 2, add to get negative 6. Multiply to get negative 12, and you get a remainder of 0. So B is a factor. Now let's go to C because again, we're selecting 2. Again, change the sign of the divisor, which is positive 4. 1, negative 3, negative 4, positive 12. Again, for the coefficients, bring down the first. 4 times 1 is 4. Add together to get 1. 4 times 1 is 4. Add together, you get 0. 4 times 0 is 0. Add together, you get a remainder of 12. So C is not a factor. So let's check to make sure that dx minus 3 is also a factor. So I'll just go down here because I ran out of space up there. So then change the sign of the divisor and then set up the coefficients. Bring down the first. 3 times 1 is 3. Add to get 0. 3 times 0 is 0. Add, you get negative 4. 3 times negative 4, negative 12. Add, you do get a remainder of 0. So both B and D are factors. Then question 20 is asking which statement is incorrect about the graph. So again, which statement is false? So here, A, the graph is decreasing over the interval 0 to 2. So the x values from 0 to 2 over this interval, is our graph reading it left to right? Is it decreasing? Yes. So this statement is true. The graph has a positive leading coefficient. Well, notice how both of our ends are going upward towards positive infinity, making this a positive leading coefficient. So again, this is true. As x values approach negative infinity, so now as we're going to the left, right, towards all of our negative values, what is our y values approaching? Well, here on the left, again, it's going up towards positive infinity, but this says negative infinity. That's why the answer was C. Question 21 is asking us which of these equations represents our sketch here. Well, again, we need the zeros, which here are negative C, negative B, and A. And again, writing in factored form, so change the sign. But also consider multiplicity. So notice how at negative C, we have a bounce. So we have a multiplicity of 2. Then we have a slice at negative B, so multiplicity of 1. Slice at A, so again, multiplicity of 1. So I'm going to mark off A and B because we need that exponent of 2 here for that multiplicity at negative C. Also remember, when writing in factored form, we're changing the sign. That's why the answer is D. Question 22. Which expression here is equivalent to this expression, which really is division? I'm dividing this 7x minus 3 binomial by x plus 2. So we can use synthetic division. And I've got negative 2, right? Change the sign of the divisor. Now I've got 7 and negative 3 here. Bring down 7. Now I'm going to multiply negative 2 times 7, which is negative 14. And when you add, you get negative 17, which is your remainder. That's why the answer is B. Then question 23, which represents the horizontal and vertical asymptotes of our equation here, our function. Now remember, horizontal is y is equal to, where we look at the degree. Notice how the degree, the exponents are the same, so we just take the coefficient. Coefficient here is 1, coefficient is 1. So 1 over 1 is 1. So that's why the horizontal asymptote is y is equal to 1. So I'm going to mark off A and B based on just that information. And then actually, technically, I could also just say now the answer is C. But I'm going to go ahead and check because D says that y is also equal to negative 1. So I'm going to go back, though, and let's just make sure that we do end up with these vertical asymptotes at x is equal to, and we're saying we have 2 of them. Then just like before, we're going to factor. I've got x plus 1 times x plus 1 over, then factor the denominator. So this is x plus 4 times x minus 1. Now notice there were no common factors, and we always get the vertical asymptote from the denominator. And again, remember that this is setting it like it's equal to 0. That's why we're changing the sign. So we have x plus 4, which is x is equal to negative 4, and x minus 1, which is x is equal to positive 1. So yes, the answer was C. Then question 24. Susan simplified and got this as the answer. So which of these problems could that be? So first off, I'm going to notice that I need to make sure that in my numerator, I basically have a GCF of 7. So I have 7 times x minus 2. So keep that in mind that I'm looking for this in my numerator. Now in A, I do see a common factor. So I could cancel out the x minus 5s. Now notice by doing that, we have gotten rid of the x minus 5 that's needed. Because we are left with, yes, 7 times x minus 2, but only over x plus 3. So that's why the answer is not A. Then B, we're adding together. But we need a common denominator, nothing in common, so we multiply them to each other. So here I'm going to multiply 2 by x plus 3 and multiply 5 by x minus 5. So now here I've got distribute the 2. So I've got 2x plus 6 plus distributing 5, 5x minus 25. So this would be in the numerator. Adding like terms, 2x plus 5x is 7x. 6 minus 25 is negative 19 when we need negative 14. So B is not my answer. Now notice in C, we're just multiplying where we just multiply straight across. Notice how I've got 7 times x minus 2, which matches the numerator, and x minus 5 times x plus 3. Nothing canceled out, and it matches. So that's why the answer is C. Now, for those who thought it was D, because when you factor, however, this is division, so this is keep, change, flip. So yes, you keep the first, but you multiply by the reciprocal, flip it. So now notice how x minus 3 is now on the numerator, which I know I need here 7 times x minus 2, not x minus 3. So that's why it's not D and why the answer was C. Question 25, we're subtracting. And remember, when adding and subtracting, you have to have the same denominator. Now, I notice that I can factor this new denominator and use x minus 5 times x minus 1. Now, the second denominator only has x minus 5. So what is it missing? What factor? It is missing x minus 1. And so now I have my numerator of 11x minus, right, because we're subtracting, then distribute 3x here. So 3x squared minus 3x from 3x times negative 1. Then because we're subtracting, distribute the negative. So we're going to combine in the numerator because the denominators are the same because we have multiplied by that missing factor here. 11x minus 3x squared, but plus 3x. So now notice here you've got negative 3x squared, 11x plus 3x, which is 14x. That's why the answer is B. Then our last question, number 26. Misty solved this equation and found that the solutions of 1 and 3. Which of the following statements is true? So first off, remember when solving an equation, always identify the extraneous solution. So here in this case, x cannot equal, according to our denominators, 5 and 3. So these are the extraneous solutions, what makes this undefined. Then here, notice what our equation's equal to. This is x minus 3 times x minus 5. So if I wanted to go through here and solve, notice how, again, we need to get the common denominator and multiply by the missing factor. So x minus 5 here, the first is missing x minus 3. So that's why we're going to multiply by x minus 3. Then the second is missing because it only has x minus 3, so we need to multiply by x minus 5. So I'm going to multiply by x minus 5. So here, distributing, well, that's just 1. So I'm left with x minus 3. But then plus, I need to now distribute the x to x minus 5. So I've got x squared minus 5x, which is equal to negative 6. Solving the equation on the left side, I do notice that I have like terms to combine. And I'm going to rewrite in standard form here. I've got x squared, but x minus 5x is now negative 4x. Minus 3 is equal to negative 6. We're solving a quadratic, and quadratics always have to equal 0. So that's why we need to add 6 now to both sides of the equation. Here we're going to end up solving x squared minus 4x plus 3. What factors multiply to get 3 and add to get negative 4? Negative 3 and negative 1, which means x is equal to 3 and 1, like what Misty got. However, go back and always check. Notice how 3 is extraneous. So because 3 is extraneous, 3 is not an answer. That is why the answer here is A. 1 is the only real solution that this equation has. X is equal to 1 because 3 is extraneous.